Okay, going down the rabbit hole for ovarian biology. Let's do ovarian axis. All right, hypothalamic pituitary ovarian axis. And then we'll do, ooh. That's a good place to start. Hypothalamus, pituitary, and gonadal. We're a single entity because these glands often act in concert. Blah 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 blah. Okay. Regulation of normal bodies, reproductive immune systems. Gee, okay. I've seen this before. To luteinizing hormone, follicles. Okay, I've seen both of those before in literature. Haven't seen them in under a microscope or anything. And you wouldn't unless it was electron microscope. Anyway, conas, blah blah blah. Liver. Yeah, she's much hypothalamus and pituitary direct. Neuroendocrine function. Adrenal. Thyroid. So that means that the gonadal portion is going to be tied into the thyroid and to the adrenal cortex. And why is that? Well, because here they're saying the hypothalamus and pituitary are directing neuroendocrine function. But if ovarian aging or gonadal aging is affecting these two things here, then they're going to get messed up. And how do I close this? Then if the ovarian or testes aging affects these pieces because they're acting together, then it's also going to affect anything that those things are affecting. So thyroid and adrenal systems, whatever. All right, regulation, blah, 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 blah. Shown, in response to juice, these cells produce which travels the bloodstream. Oops. Ovarian, estrogen influence feedback loop. Positively. Is there any way to reduce the contrast or the brightness of this? Let's see here. Night light. Okay, that works, I guess. All right. So HPG axis controls uterine and ovarian cycles. Estrogen help to prepare the follicle and ovarian uterus for the passage. Secretion of progesterone. Placenta will take over the secretion of progesterone. Huh. Starts secretion. Levels also control the uterine. So I guess as long as you have some amount of, I've heard about that. Okay. Also control uterine. Channel housing proliferation. Activation of HPG during puberty also cause individuals to acquire secondary sex characteristics. Citation definitely needed. FSH, so it's distinct. Androgen binding hormone, protein, testosterone, inhibits the hypothalamus. Inhibin, I think I've seen that term before. Activin, definitely seen that before. Relatively constant. Okay. Primary. During puberty, HPG axis. Okay. During puberty, the HPG axis is activated by secretions of estrogen from the ovaries or testosterone from the testes. The activation causes physiological changes. Once activated, HPG axis continues to function in men for the rest of their life, but becomes deregulated in women, leading to menopause. Okay, here's the money. Deregulation is caused by lack of oocytes. Okay, I mean that's what I thought, and so I've been going around telling people, so that's good. That's accurate. Because some people apparently believe that it's not the lack of oocytes, that it's something else. And I'm not sure what else it would be, but like, I don't know enough about biology, but it seems like this is pretty obvious. So over the several years, okay, so what we've got to do is find a body of evidence that either proves or disproves that statement, because Wikipedia is not sufficient. So we'll start here. Brain forgot aging. Aging of the female. Okay. All left sides. In women, depletion of the cold ovarian follicles and the associated decline in circulating, traditionally recognized as being the ultimate markers of menopause. Well, here's the thing. I've heard that you can increase E2. What are they calling E2 here? E2 is 17 beta estradiol. So I heard that you can upregulate the hormones and still you won't fix the problem, which if it was just depletion of if it was just the ovarian follicles that were making the hormones, and if the hormones were the real signaling thing, then simply replacing those hormones should cause you to stop exhibiting whatever, but apparently it doesn't. There's more to it than that. I suspect that there's just other forms of signaling and integration that the germline has with the rest of the body that causes it to be more than just a hormonal repopulation problem. So I think that's where there's the controversy is like, yeah, they tried replacing the hormones and it doesn't work to like stop menopause. Anyway, so pituitary is likely to contribute to the reproductive decline since LH response and early phyllox decreases in older compared to younger cycling women. Accumulated evidence indicates that during the earliest stages of reproductive decline, prior to any changes in ovarian cyclicity and circulating E, this stage is reproductive. Any changes in ovarian cyclicity and circulating the brain level of the brain play an important role in the initiation of reproductive senescence. Wait, hold on. I need to reread this. The healing evidence in there's an early stage of reproductive decline prior to any changes in circulating to level of the brain. Okay, so it's one of those markers. Gene first surge prior to any observable changes in the estrous cycle. Observed consistent delay in the onset of LH surge and continuation in peak LH concentrations. Age-related change in our LH release likely reflect alterations at the level of the hypothalamus rather than the pituitary because they occurred in age prior to any change in pituitary responsiveness. As we've never observed a change in GnRH neuron number during middle age, an age-related change in GnRH neural activity is more likely to contribute to Alzheimer's and knowledge. So in terms of change of function during electric restriction, quantify the expression of the immediate early gene. CFOS is an indicator. We say identify increased neural activity in individual neurons because it's not detectable in peripheral blood. It's a few in number and the populations are diffuse. We show that in middle age, rats, huh? You want human data, but that's okay. Showing middle age, estrus. That different inputs to genes, neurons change in early stage of reproductive age. Okay. Onset of reproductive senescence. The complex balance between and timing out of stimulatory and inhibitory inputs to GnRH neurons. Evolve. To reduced. So if we're getting into just senescence, okay. So here we have some kind of brain remodeling program. Okay, let's do this. Where's ovarian? Where did I put that thing? Ovarian biology is here. Okay, hypothalamus. Pituitary. The lag. We gotta fix this lag. All right. So there's non-directed hypothalamus, pituitary. And undirected. Okay. We also have the pineal gland, which is over in circadian rhythm, but I don't want to draw weird arrows at this stage. So okay, sorry. Going back over here. Aging of circadian signals contribute to reproductive decline. Rise in circadian. Uncoupling of the temporary coordinate rise in estrogen or estradiol, the light dark cycle. Specific time or the light dark cycle. Circadian rhythm is produced daily. What? Wait, say that again. Rodents that are ovariectomized and treated with ET have daily afternoon surges of LH relative to the light dark cycle, indicating that the circadian rhythm is produced daily but requires high estradiol levels to be expressed. Okay. That's some really old research too. Man, they found out some of this stuff like so long ago. Okay. Lesions of the and by old I mean a lot of people are still alive who are like, I remember 1975. It's like, yeah. Our gradient about what old is always relative. Anyway, lesions of the SCN abolish estrous cycles in gonadally intact females. Oh, for the love of God. Okay, so now the suprachiasmatic nucleus has an effect on the SCN. Okay, we're going to save this first, and then we're going to open up longevity 2. This is the spiderweb version. And for the spiderweb version, we want to connect, what were we connecting? SCN goes to estrous cycles. So SCN, where's ovarian biology is here. Oocytes, estrogen, I guess, estrogen cycles. Let's just connect this over here. And we'll come over to rhythm. Okay. So there's oocytes are connected to that. Is there some kind of malware on my computer or something? Jesus, it's a lot of random lag things. I'll have to check it after this. Anyway, so so there's what, the pituitary. Hypothalamus. There's the oocytes. They're going to so menopause leads to sleep problems, or is it that sleep problems lead to menopause? Eliminate daily afternoon surges and treated. include the rhythm that regulates the cellular surge and restore cycles generated endogenously or circadian pacemaker located in and that the. Okay. Circadian neuron signals from the mammalian biological with the Is there a diagram in here anywhere that like shows what's going on? God damn, of course they didn't put one in. This is why we need these diagrams, so that we can just kind of contextualize like what the heck is what are you talking about? What is going on here? Okay, so okay. Driving force behind realizable and timing of inputs to the gene. In middle age, orchestration of this balance is deteriorated by but from what? And it should manifest in reduced gene reduction in magnitude delay. Change the rules, signaling factors may contribute to this observed age effects on the excitatory input from the amino acid glutamate is a critical stimulatory factor. And however, during aging, glutamatergic input to the brain regions containing appear to decrease. Let's just go through here then. Bran and Neil Perry, both 2005. Bran, 2005, expressions. Jesus Christ, these these titles. Okay. Receptor settings, the proestrus luteinizing hormone surge, antiprogestin treatment and aging. Okay. So first things first. Of the LH surge. We'll say that. I think we'll know which paper it's referring to, but I honestly don't understand proestrogenic moodiness hormone surge. So we'll just look that up and see if we can find anything. What about in humans? Unless this is just a thing that happens in rats. Proestrus. Jesus Christ. Okay. Okay, so this is rats for sure. Human oestrus. Okay, so we don't have to worry about any of that stuff. God damn it. Okay, so this is all rat related, and that's just not important. So, we don't care about that. And we don't need, so Mm. Any diagrams? Nope, of course not. Just walls of text everywhere. Phase of humans occurring near ovulation distinct from other phases of the ovarian cycle in terms of. You argue this long-standing assumption is wrong. Review evidence of women's fertile phase sexual differences in various ways of sexual. In fertile phases, in particular, when fertile in the cycles, women are particularly sexually attracted to various features that likely are indicators of genetic quality. So women's fertile phase sexuality shares. And the term estrus appropriately applies to this phase in women. Function of women's non-fertile extended sexuality, and based on her findings, sexuality in women shaped function in the context of extra-parent. Based on byproducts of not because we need signal cycle-based fertility status. Okay. Phenomenon. Okay. Is there any? Is it just behavioral? What? We can close this. What are we looking for right now? We started with hypothalamic pituitary ovarian axis. I think we just continue on this line. Okay, great. What the hell? Pituitary hypothalamus. Human. You see this? Mice. Diagram of human ovarian pituitary axis. Wow, fantastic. This is better. Menopausal ovary. Hypothalamus, pituitary gland, so GnRH. Why is the hippocampus involved suddenly? Oops. Aging brains of special reference. When did this come out? 2019. Good Lord. Okay. Great. Now we have to go find the full text. Oh, wait, public full text. Oh, here we go. Okay. Good Lord. So now we have hippocampus coming in as well. Well, So if luteinizing hormone, like what, like, okay, here's what I want to see. What are the consequences of, reduction or increase of luteinizing hormone on the hypothalamus, on the pituitary? Same thing with follicle stimulating. Wait, no, these are referencing the cross. What is this thing referencing? Estradiol. Like for all these different things, what's the consequence of having low versus higher amounts? This is why we need organoids to test what occurs, like in terms of functionality. But if it's a system, you might not see the full change unless you have the entire system present, which is why you want like a mini body on a chip. You have shrunken organoids for each of these things, and then you can like manipulate it. God damn, that's gonna be difficult. Well, I mean, I'm sure people out there are trying to work on this, right? I'm talking about liquid metabolism. Okay. Well, let's continue looking at other diagrams. How about that? Ovary, testes, testosterone. It's just a fancy, okay. Oh, what about this? What's this? Where is this from? Theca cell. What's a theca cell? Theca cell. What is a theca cell? Associated with ovarian follicle essential fertility issues and androgen substrate. So back over here, wait, yeah. Save as a graph file and make sure that they're correct. This is longevity 2. The other one was longevity 1. We'll open that back up. Okay, where's the ovarian biology section? No, it's down here somewhere. Yep. Okay. Where? Oh man, I swear to God, I had. Oh, I remember. Oh, oops. Oops. Ovarian biology. Here we go. Here we go. All right, this one. Stromal. Oh, I did have thecal cell. Okay, so that's already there. How about diagram of oocyte maturation? Okay, this is good. Mm. Resistance, potential, cells, mammalian, does that mean rats? Okay, humans. putative ovarian stem cells, isolation of these cells is challenging, and to debate as to their existence and the validity of DX as the main marker of their isolation is being questioned. Different groups are various to determine and to describe body evidence regarding the initial characterization of isolation growing. Metadata induced pluripotent stem cells and enzymes in ovarian follicles as a basis for such one thing to remember here is that regardless of the fact that regardless of whether ovarian stem cells exist, there still is attrition. So either they're not being used for some reason if they exist, or they just don't exist. So we'll see. Okay, this is good. This diagram is good. What was this? That's not, you don't need to worry about that. Don't need to worry about that. We've got that one already. Okay. So, primordial follicle formation, follicle. Is a zygote here? Zygotine, pachytene, leptotine. What the heck is going on here? Zygotine, leptotine, pachytene. Oh, diplotine. Oh, God damn it. Okay. But oocyte growth, primordial, primary, early. Ogonia, proliferate and germ cell nest form. Nest breakdown. Pre, early. What? Okay. Any other diagrams that actually have an oocyte in them? Oh, this looks promising. What is going on here? Germ cell, oogonia, primary oocyte, secondary oocyte, ovum. Okay, all right. This is what I was looking for. Jesus Christ. Meiosis. Okay, so primordial germ cell. Goes to oogonia. Where's oogonia? I swear to God, I had it somewhere on here. Oh, here we go. Primary oocyte diploid, so oocytes. oocyte. I don't think I had primary oocyte, so we'll do that. Oocyte. Secondary oocyte. Ovum. Okay. Oh, here we go. Oocytes. I guess these should all go inside of there. We'll do that. The spacing is a bit weird, but okay. Let's find a thing. All right. Okay. Um, Anything else? Primordial follicle, primary follicle, secondary. Mm, no. One cell cycle, ovulated oocyte. Basically, what I'm trying to find is from fertilized egg going through to fertilized egg, the entire cycle between creation of a body and all that kind of stuff. There's physical continuity of the germline. So I'm just looking for like the early physical continuity. How's that work? And how much do we know about that? I think that's pretty much it. Everything seems to be just rehashing of the same thing. Okay. Oh God, Keg. Of course they did this. Let's see what Keg has for us. Oocyte maturation. Mm, this is just the pathways within the cell. Okay. Follicle. Okay, that's fine. It becomes a blastocyst after being a zygote. Okay. Blastocyst. Zygote. To blastocyst. I'm sure I'm getting some of these wrong, but we can look it up later. Blastocyst. Um, ovum. Zygote. Maybe just zygote blastocyst diagram. Egg, zygote, blastocyst. Zygote. Okay. So what happens before it becomes a zygote? So it's ovary, oocyte, oocyte. Yeah, great, thanks. So oocyte turns into a zygote, I think. Secondary oocyte, fertilization, zygote formation. Okay, all right. So we can do this, this. I'll just pull it down here to the bottom. Now, these things is follicle formation. And I wonder if it includes the germline within it. Because then definition wise, it's going to get a little tricky to show that hierarchy. Because if the germline cells are kind of like a zygotine contains the zygote and then a pachytene, no, that wouldn't make sense. Whatever, I'll ask later about this. Okay, so we have this resistant test. I'm not sure what's going on with these headphones, but they're messing up every so often. Wireless, am I right? Unless they're just close to battery dying or something like that, I'm not sure. Energy sensors in female mammals, roll of mTOR, insert one. Jesus Christ. Hypothalamo pituitary ovarian axis. Roll of mTOR, AMP-K. See, what the hell? Everything's tied into this. There's no way that like all these people are right about this. Like, it can't, I mean, hello. God damn it. Great. When did this come out? 2021. Female. That disorders. Okay. We have premature ovarian failure and polycystic ovary syndrome. Yep. We have those in the bag. Okay. So neuropeptides as regulators. Female rats. Don't care about rats. Don't care. Um, How about this? Let's go on to the pineal. Was it pineal thyroid ovarian axis? Thymic? Oh, this is probably useful. Seems like a pretty old paper, but one that might be useful. Holy shit, this is old. Oh my god. What the hell? Okay, we just need to save this though. Ovarian function and all right. Insulin. Yeah, conservative ages. The germ somewhat conflict. What conflict? Smack loss in the germ. Creating body. Somatic death is a germ cell triggered event and is established as demolition fixed default state. Pollination to measure reproduction in a world of fixed finite resources. Is the stress resistance dependent phenotype on the somatic resilience that counters the germ cell inflicted death? Aging is a survival. I gotta talk to this guy, Kurt Heinen. Neurology. I gotta talk to this guy. I gotta. Okay, let's just. This is supposed to true biological mortality is a deprivation syndrome driven by a germ some conflict. Kurt Heininger. Is he alive still? Hopefully he's still alive. assumed with what versus how do we contact him? No. God damn it. Okay. Open it up in the other window. And where's his like lab page or whatever? Like he must have a lab, right? Okay, well, that sucks. But we can at least go to here. This is from 2001. Now he's gotten later one, this 2012. Deal, wow. Versions, blah, 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 blah. Goldsmith describes the situation as follows. Impossible. Possess genes that are specifically designed to cause physiological decline with age or control how long we live. Genetic control only indirectly, and aging is a product of evolutionary neglect, not evolution intent. Bolshansky. Okay. Yeah, I didn't know he wrote that. All right. Regardless, I need to contact this guy. What is this? This is nothing. This is what we were looking at before. This Kurt Heininger. All right, well, we'll just do that right now. But I think that's enough for today. So we will stop sharing and stop recording.